Now sorry, I haven't had a chance to actually update D2L. I will update it maybe tonight. I need other stuff to do tonight. And I am an idiot. I reorganized my material and I didn't count. So we go 1, 2, 3, 4, 5, M7. That's how we count. Now, we have covered most of the control structures. We know how to do ifs and cases and all sorts of conditionals, right? We know how to do loops a little bit. We know recursion, we know functions. Now we are going to start talking, and we know how to use objects of a class. Now we are going to see how to define our own classes. If you remember, we used points and things like that, right? So the idea that we have been going through and that I hope to get into your brain much more than the particulars of Java is this idea of what we are doing is creating our own language, right? So that the problem that we're trying to solve becomes super easy, right? We have been concentrating on verbs, on movement, right? Our functions are kind of like verbs. So you say, go do this, right? Now we are going to concentrate a little bit more on nouns. Classes and objects are nouns in your, if you were talking about your problem, right? You'd find nouns rather than verbs. So the idea is we can create our own data types that correspond to our problem. Whichever problem we are going to solve, we can define all of that stuff, and then eventually our problem becomes super easy, and we just create 2 instances of something, call 2 methods on it, and it just works. Because we have built all of that stuff. So creating classes is like creating our own vocabulary. A lot of this stuff, we tend to cheat, as usual. The harder parts of computer science are much closer to philosophy and psychology and human stuff. But given that those are hard, we teach you the mathy part. Actually understanding what the heck the user wants and being able to express it precisely as requirements is a lot harder than going and implementing this stuff in programming, right? We are teaching you the implementation. The other stuff usually takes 10 years experience. It's just, and it's a lot closer to philosophy. So we are gonna skip some of this stuff, but keep in mind that many of these things are really, really hard, right? There is only 2 hard problems in computers: naming, caching validation, and off by 1 error. So this is, the naming of this stuff tends to be really, really hard. And it's because it's not computer science, it's philosophy, it's whatever you're doing. Now, one important thing is we need to distinguish between classes and individual objects or instances. Normally, we're going to use a computer to keep track of bunches of things. So we need to be able to define what does each thing look like, but we don't want to be defining, if we're going to have, Kennesaw has 20,000 students, right? We don't want, when we're programming, we don't want to talk about the 20,000 students, right? So what we want to do is to define what a student looks like, what kinds of things you can do to students, and then, right, you will iterate over a collection of students and do whatever you need to do to them, right, or with them. So our class acts kind of as a template or skeleton. It defines what all the instances can do. In our examples that we're doing, you have a point class that has x and y, and then you have instances which you normally store in variables, p1, p2, whatever, that have actual values of x and y. What we're going to see now is how to define a point class or something like that. So we are going to define a class person, because of course, and then we are going to go defining instances, which would be Jane or John or whatever. Important thing, it is not quite as stringent as before, but Java decided to match class names to file names. So for the most part, your classes will be defined in a file with the exact same name as the class. And we mean the exact same name as the class. Capitalization is important. So if your class name is person with a capital P, your file name will be what? Person.java, right? Also with a capital P. Does that make sense? So be careful, because that tends to be a standard problem. It's not quite true. If the class is public, then it needs to be in its own file. If the class is not public, then it doesn't have to be in. I will cheat and define static classes inside other classes just to put stuff in one file. It is horrible practice, you shouldn't do it. It just makes it a lot easier for me when I'm teaching to have it all in one file, so we just go up and down rather than go switching.
So if you said it was a uppercase, can you just rename it, or do you have to?
You can rename classes and files and things. And files are just files; they're just stored in your folder, so you can go rename them. Let me create a new package. Call it objects. By the way, also in Java, if you remember, we have packages, right? So our point class was really not just point, was java.awt.point. Your package name will correspond to the folder structure in your project. You can change it, but that's kind of the default. So in here, I can create a new Java class. Let me call it person. The IDE tends to be nice and tell me which package I'm in. So I'm defining a class called person. What can I do when I'm defining a class? The simplest thing that I can do is define the fields. Which kinds of data, which state would each instance, which each object be able to contain? If I'm defining a person, what can I define? Their name, right? So let me do, the name is a string name. For now, let me do this. Public string name. Slightly bad, but it's okay. Just to put another example, let's do int h. Let's see. What is my example? Okay. Let me do first name and last name.
Do you always have to put the access modifier in there? Or does it just default to public if you don't?
No. It defaults to something that you normally don't want. Defaults to package. Defaults to classes within the same package can access this stuff, but nobody else can. The default is something that you normally don't want. By making it public, we are saying everybody can access it. Which is not a good idea, but it'll work for now. I'm going to define my main here just for fun. We can probably create, we probably ought to create a different, let me do this and switch between files. How about that? Now that I have my person class, now I can do person p1 equals new person. Right? Do you remember? It's new, nothing magical. But now my p1 is going to have its own first name, its own last name, its own age, right? And since I made it public, I can modify them. So I can do p1.age equals 23, p1.first name. Yes?
Can we put first name, comma, last name by comma?
In this?
Yeah.
Yes, this is basically, the syntax is almost the same as declaring variables.
So
They are instance variables, so you could do commas. You could also do this if you prefer.
okay. And other thing, why we create two classes like this person class and main class and again?
This is just because that is more commonly done. Because what's going to happen is that maybe if we were to do, say, if you're representing, we haven't done much of this, but if you're representing, imagine that we're going to represent schools. We would have a class for students, a class for teachers maybe, a class for classes, for courses, maybe a class for classrooms, maybe a class for, right? And so all of them are going to go on their own file. So it doesn't make a lot of sense to have mains for each classes. So we would have a class that only contains the main or something like that. That's what I'm trying to model. Those are good questions. It's, yeah. Sometimes I'll do it like this. Sometimes I'll just create a file because use it, cheat and put it in one file. But this is much more common because that's what you normally want to do. So first name, Orlando. They named the city after me, isn't that cool? We can do things like this. Does this make sense? All the same stuff that we could do with points and things like that, except that now we defined what goes here, what's the state for that class. Is this cool or what? Now, being able to store bunches of variables, right, in one place is useful, right? Now I can have all the data for that person in the same place, right? Their first name, their last name, and their age. I can also define methods. By the way, these variables, right, are instance variables. Each instance of the person class has its own variable, has its own state, just like it happened with points. So now we can go define methods. So a method looks like a function, right? We have been defining methods. We define them as static because we didn't want them to be attached to an instance. In this case, they'll not be static because they'll belong to the instance. So each instance would generate a different value because it will have different states. So for example, how can we generate the full name of a person?
First name plus last name.
Yep. within a method, I can refer to the current instance that the method is operating as this. Right? So when somebody calls p1.getFullName, it's going to be using p1's first name and p1's last name. When somebody does it on p2, it's going to be using p2's first name and p2's last name. Does that make sense? So let me go back to main and then do system.out.println p1.getFullName. Sorry?
I was telling that if you type SOUT.
Oh, SOUT is TSVM? Oh!
It's like the coolest thing ever.
Nice. Thank you. Beautiful. Yay! It works. Does this make sense? So, how about how do we put the names formally? Last comma, right? So what do we do? Ah! Hate you idea. Hate you idea.
In your empty string, just put a
Comma space? Does this make sense? Isn't this cool? Now, slight simplification. You don't have to write the keyword this. You may want to write it for now, so that you get used to the idea. You don't really have to, and in fact, normally people don't write it. So you just do this. Does that make sense? And it will go find it as the instant variables. You need to realize that those are instant variables. So actually in here, if I do p2's.getFullName, I'm gonna get a different value, right? Make sense?
Say in this class you want to create a method to get your age. If you name, which I guess you mentioned, but if you name the method age and then you said just like get age, would you have to do this dot age when you set it there so that way it knows you're talking about a different one, or that you?
Sometimes.
It's just simple enough to name
If you start being a language lawyer, it's like, oh, what, right? Forget about it and name them different things. It's going to confuse you. It's going to confuse everybody else.
I've seen an instance when you would have to put this.
The only place where you have to put this, and we'll do it in a second, is if you have something else with that same name.
Okay.
If you define a parameter with the same name, then it will. So for example, if we are gonna do by the way, normally get, right? We tend to, in Java, it's customary to the methods that only get stuff, right? Is get whatever. There's a very strong assumption that that method will not change the object, right? And again, just like we did with functions, your functions shouldn't be changing stuff. Your methods normally shouldn't be changing stuff. That way you can call them and you don't have to worry about what happens after. Sometimes your methods should change the state. Like you want to be able to change the state of your objects, potentially. Normally in Java, those methods have a set in their name or some other thing that tells you in big red warning lights, you are going to change this stuff. So let's do public void set first name. I'm going to set the first name to something. I need to pass it a parameter, right? The value of that first name. What type is that parameter? What's a good name for that parameter? I could do this. If I do that, I back myself into a corner. I have a parameter and an instance variable with the same name. So in that case, I can do this dot first name equals first name, and remember that this one is the instance variable, and this one is the parameter. Does that make sense?
Is it kind of dangerous to do that?
This one is super common, so people tend to not consider it dangerous. I tend to do this.
What is the p underscore? Is that
Just something to change it, and it's a parameter, so p underscore seems like a very good name for my parameter.
I don't know if it has like a connection to the name of your new class or anything. No.
It's just a name. Some people tend to do the reverse and name their variables with something, like usually an underscore in the name of the variable, so that way you don't get the class. In my classes, I tend to do this. At work, I would normally do it the ugly way, because everybody knows. Slightly more confusing, but you get used to it. For at least this week or next, I would strongly recommend that you write your thesis and that you name your parameters with different names so you don't confuse the heck out of yourself. Right? Does that idea make sense? And I will try to do it like that for this week and next to not confuse you guys. But you are more than welcome to do it any way that works for you. Now, if we do these things, let's see, what's the order in there? Methods. Okay, let's go talk about constructors. We were able, if you remember, to do, and this was very convenient, to do point and my IDE was nice and imported this stuff. Do something like this, right? And that would initialize my object automatically rather than having to write a bunch of lines, right? What were these things called? This is a constructor because it builds an object, right? When we define our own classes, we can define our constructor. A constructor looks like a method with two differences. One, the name is the same name as the class, the exact same name with capitalization. The second difference is it doesn't have a return type because it doesn't return anything, it just builds on the object. Doesn't have void as return type. It actually does not have a return type. So, given that the name of my class is person, what would be the name of my constructor? I can do string Then what would I do? This dot first name equals what?
Would you make the age and int instead of?
Ah, yes. Thank you.
Okay, the constructor is supposed to be in different file or
No, in
same-
Java it has to be on the same file.
Oh.
In C++,
It's
C++
separate.
messes up the files in different ways for each file that they can have.
Yeah.
That's why Java does it this way. When you take data structures in a semester or two, you will do it in C++. So you'll learn a different language with different design choices. H files in C and C++ are a pain in the neck to wrap your head around. Java is a lot simpler in that way. C++ was defined in the late 80s, early 90s, late 80s, or actually early 80s. Whereas Java is mid 80s. C++. Java became popular in like 95 after 10 years of seeing what sucked in C++. And so it looks a lot like C++, but it's much simpler in many ways. Then C# was defined 10 years later, and it sucks a lot less. And other languages suck less because you see what sucks, right? And they suck in different ways. But does this make sense? Constructor makes sense, and
Can you use a constructor that pulls one of your methods? So instead of saying, we don't want to set up like a parameter for
one
first
sec.
name and last name, can we just put full name, get full name or something? Or?
Not get full name, right? That wouldn't make sense. But I could, instead of doing this, I could do. So I can call my own methods in the constructor.
Would you normally do that, or is it just you can't?
It depends on what you are doing. For this super simple stuff, no. For who knows what the heck you're doing. Like one of the standard examples is like complex numbers. So you may have may build it with real coordinates or polar, and so you may be calling your own methods, right? If you construct it with polar coordinates, then you would call stuff to start in different ways. But we can do an example, maybe.
Let's go.
So you can do whatever. Does this idea make sense? Yes.
So if we use the constructor, then we don't need to use the setter method, right?
Yes. Now the constructor is only called when you create the object. So if you need to change the value later on, you still need a setter method. Right? It's just you don't need it. Actually, it is not a bad idea to define your classes to be immutable, and then they can never be changed. You build them, when you construct them with a constructor, you pass all the values and you never change them. That's a good design choice, but sometimes you want to be able to change it. So the setter methods allow you to be able to change it. Does this make sense? I seldom do this, but we can define overloaded constructors. That take different number of parameters, just like we overload methods, we can overload constructors. We could cut and paste from here, and that would work. We could just cut and paste these two and delete this guy. We could set age to some initial value. By default, people are 18. Depends on what you're doing, right? If you're doing college students, then it may be a reasonable assumption. You can also do this, which is weird syntax, which I almost never do because I never remember this stuff. Only within another constructor you can use this as a method to call a different constructor. So this calls the constructor with 3 arguments.
In second constructor, when we take parameters, we didn't take age. So
That's the point, right? If we take age, then it would be this one.
okay.
But what we are saying is it is different because it only takes 2 parameters, right? And what we are doing is we'll set the age to be 18.
So how can we set? We are not declaring any parameters.
No, we are saying if you don't tell me what age you are 18. Just completely arbitrarily for no particular reason.
Why are we doing it? Needs to make it different. That's why we are declaring.
To make it so that people outside can call it like this. What age is P2? 18, right? Does that make sense? Reminder, we are going over syntax. Would you actually do this? God, no, right? Why the heck would you choose 18 as the default value? In a business sense, it probably doesn't make a lot of sense to do that. But
instead of changing the setting the value, can you set like a boolean for it so that age has to be between 0 and 100 something, so that way just try to prevent someone from keying in like a typo?
You could. We're later on we'll talk about exceptions. What do you do if somebody tries to create an object, a person of 150? Like
Yeah.
programming wise, so we'll see what you can do, but for now assume that yeah, normally you validate on input. No, nothing here.
Okay.
And we could do similar things. Say just the first name. And in America, if you don't have a last name, what's your last name? Doe. Don't ask me why, but that's it's not my problem. My mother's my second last name in Mexico is actually Espositos, which we think it actually means orphan, and it was what was given to people who were orphans. Somebody in my family tree was an orphan at some point in time, and that's in the US we put Doe for when you don't know who they are, right? At least that's what they do in all the crime movies and TV shows.
So you're entering their name and they don't have one. So instead of putting no, so you didn't initialize that, could you put null? And
You could put null, you could put, right, depends on what you are doing.
Yeah.
You could put null, you could put an empty string,
Yeah.
right? Maybe nulls tend to be horrible, so maybe an empty string would make sense, right, rather than though. It is fairly common to define at least one constructor and then to define setters and getters for all the fields. And then it is actually a very good idea, if you define setters and getters for the fields, to not make these things public, make them actually private. And we're going to talk a little bit about that stuff. So I could do, for example, I could do this. You can never change. Oops. Now we don't have a set first name, right? So I have to come and change it. If we define it like this, you can never change the object after it was created, right? You're allowed to set values on the constructor, but nowhere else. And you would not even be able to directly get the first and last name. By making these things private, I am saying nobody can access them, only me. Only things within the class, nobody else.
Can you still access the methods that you created?
Actually, no, because I'm an idiot. I need to make my methods public,
Okay.
and then they can be accessed.
So it's almost like you can create these classes, it's almost like widgets or tools that you could use, and then instead of having to keep reinventing the wheel, you can just kind of keep them and then just
Exactly.
call them whenever you need to.
Yes, that is the idea. You're creating your own language,
Yeah.
and you can actually create classes that use this, right? You may have a, we'll see there's a bunch of kind of generic classes. We have, like if you're defining GUIs, there's a bunch of GUI stuff that makes sense. If you're doing databases, there's a bunch of database stuff that makes sense. There is collections, things to keep bunches of things. But other than those generic classes, there is a ton, what you end up doing is doing your own classes, right? So you may end up having a course class that uses your student class and has a collection of students enrolled, that kind of thing. So you end up building your own vocabulary, building your own idea of the world, and then in the end your main should end up being relatively simple. Maybe.
Essentially just creating like a big toolbox of tools that you use to fix things or solve problems.
Yep, that is what you're doing. Isn't this cool? Now we have explained almost everything. The only thing that we haven't explained is the static piece, right? If I define a variable to be static, it belongs to the whole class. Every instance of the class accesses the same variable. So in here I could do so what does this do? It increments num people every time somebody creates a person. So it keeps track of the number of people that have been created, right? And then I can have if my method is static, it can only access static variables or parameters, right? But so I could define this method to be static, and in here I could do when I'm referring to static methods, I usually write the class name rather than an instance, because I don't need an instance. Then I will check in a second whether you can actually refer to it as an instance. So this should print 2, right? Because we created 2 people here and here. I am not sure whether I can do this, so let me try it. Depending on the language, you can or cannot. I don't remember which way Java does it. Oh, you can. So you can also access static methods through instances, or you don't need an instance, so you can just write the name of the class. Main is static, and so what we have been doing is defining only static methods that we could access through main.
So if we put p2.getNum, we still would return 2?
Yes. Because they're referring to the exact same variable. The variable is static.
And if you didn't do that, just put getNum people.
I cannot do getNum people because it's not in this class. I could do person.getNum people.
Oh, okay. I see now. Okay.
And I would also get the same thing. I was.
This doesn't seem intuitive that, that you're calling, or that you're printing out the object that it returns, not specific to that object, but to.
Yeah, some languages don't let you do. Some languages force you to do it the last way in line 17. But Java does allow for both cases.
You say it's a better practice just to do the last one too.
That's what I tend to do. It's not necessarily better. It depends on the context. But I normally do it the last way. And I tend to do a lot more functional programming than object-oriented programming, so I tend to do a lot of the line 17 kind of things. Does this make sense? Do you have any questions about classes in general? Now, should we create other classes that do stuff? One that I love to do, because I'm a masochist, is a fraction class. What does a fraction have? Numerator and denominator, which are what? Integers, right? Oops, I messed up. You either do it like this or in 2 lines. What do you prefer? Comma or 2 lines? Like this, comma? And let's make them private. Let's define a constructor, right? Public fraction.
So you know it's a constructor because it doesn't have a
return, doesn't have a return value, and it has the same name as the class.
Okay. And it doesn't. Okay.
Let me call these things p underscore so that, right? Oops. So that you guys don't confuse yourselves. Again, this is optional, but I'm putting them. Let's do. What would be a reasonable assumption if you only give me the numerator? What's the denominator?
1.
Right? I can define how do we convert it to a double?
Divide by 1.0.
Yes, right? Somehow make one into a double, so my standard way numerator divided by double.
So if you want to convert, you can just put what you want to convert to in parentheses.
That is casting, yes. That is called casting. You put the data type in parentheses.
Could you do that from like a string to an
No.
empty string?
No. Only for numeric types. There are ways of going from like string to int, but it's like integer dot parse int and those kinds of things.
So how you put exception for denominator zeros? So
We'll talk about exceptions later, right? For now, one thing that we can do is here, right? Make this saying by if this dot denominator if you tell me dumb things, I'm not gonna listen to you.
So you just overwrite what they're doing basically.
I define what the constructor does, right? So
Would this be considered the exception, or is
no, there is a specific thing called exceptions in Java, and we will talk about it. It's just I don't want to confuse you guys yet.
so
I will confuse you. Just
what would you term that as then? Like, or is it just like
I just write it in the documentation, right? I'm not
Yeah.
gonna divide by 0, so I will.
okay?
Now there's one more thing that we probably ought to do. How can we calculate the GCD of two numbers? I think this GCD is greatest common divisor. Because we ought to reduce our fraction, right? So if the numerator is, if the denominator is 1, I return the numerator. How did this work? Consult the fountain of all knowledge.
Just do java.lang.math.gcd.
Are you serious? It probably exists, right? Did you find the right name?
I
No.
just Google what it said.
Yeah, it'll probably work. This is it. When the denominator becomes 0. Ah. Okay. Denominator equals 0, return numerator, else return GCD of denominator and numerator percent denominator. So let's see that it actually works. And this is why I created a main class, right? So I can have different classes. Fraction is in a different file, right? It's static, so I can do fraction.gcd. GCD of 3 and 5. Yeah, it died. Semicolon expected.
That's right, first rows. So you could use this to kind of like to test like your programs to see if they do what you think that they would do almost. It's like,
The main? Yeah.
yeah. Well, I mean like.
So yeah, 1 and 5, that sounds reasonable. So I could actually have public void normalize. And a public, this is private. How do I normalize a fraction? Actually, I'm gonna call it from here. And then here I'm gonna do all these things. First of all, if the denominator is 0, I'm gonna make it 1, right? Now, if the denominator is negative, we normally put our we normally make numerator negative, right? We never put the denominator negative. So if the denominator is less than 0, we are gonna do the denominator is minus denominator and the numerator equals minus right? And then we are gonna do int GCD equals GCD of the GCD. I hope that it also works for negatives. Now, only my numerator can be less than 0, right? Or let's just do halves. I can never remember how is GCD defined for negative numbers. And then I can do this, the numerator equals
This anthem
Sorry?
Uncommon.
What?
GCD for negative number is uncommon.
Oh yeah. In the elementary school, they do it with positive, so that's all I remember. And then you never really use it much later, so I don't know. So we reduce the fraction too, right? So we make sure that we put the negative on the first place and then we reduce it, right? Oh, and let me do one more thing. What happens if I do, let's do fraction f1 equals new fraction 6/4. This should have normalized it, right? And those all sorts of things. Get numerator and then get denominator. What do I expect to get? No 6, it's minus something, right, and 4, but what's the GCD is 2, so this is 3/2, right? Now, so it's minus 3/2, but I'm gonna get minus 3 and 2, right? Now, we mentioned that every object has a toString method. So what happens if I try to print my thing? Has a toString method. We'll talk about inheritance, but it, right, prints horrible things. We can define our own toString method. How could we represent ourselves as a string? How do we represent a fraction as a string? That'll make our code prettier. Isn't this beautiful? I hope that wasn't the assignment. I don't think there is. I don't think it is. You know all there is to know about classes now. We'll talk more about other things. We are kind of going to be going over classes over and over. We will do arrays next week. We have seen basic classes, then we'll do arrays. We'll do inheritance and talk about how you can organize your classes in hierarchies so that you can reuse common stuff. And then we'll do collections, which is similar to arrays. So we reinforce all of that stuff over and over. What should you do when you get home, besides starting on assignment N?
More practice.
Yes, go define more fractions, right? Define more fractions, more classes, right? Go define stuff, right? Whatever makes you happy. Go define cats and dogs and pets and products and whatever makes you happy or keeps your interest, right? Do a million of them. Use your fingers. Make your fingers remember this stuff. Make sense? If there are no more questions, I may even be giving you back a minute of your life. Or the other way around. 7:38. 7 whole minutes of your life. Any questions on classes? No? Cool.